So in this worked example, we are going to look at a frequency distribution table. And then what we are going to do is we are going to use the data that are given here to construct a frequency distribution table. So the number of credits completed by a sample of 47 students are shown below. Use this information to respond to questions that follow. So the first question is let's look at the questions, right? So question number 1 is that we want to create a frequency distribution. So the question is, what class width should we use? So we want our frequency distribution table to have 5 classes. So what class width should we use? Right, so the way we calculate class width is, okay, so class width, right, class width is equals to the range. Right, so class width is given by the range. Then we take the range, we divide that by the number of desired classes. Right, so in this case, our range is, if you look at our numbers, the maximum here, they're already rank ordered. So the maximum here is 120. The minimum is 9. Right, so range is maximum minus minimum, which is 120 minus 9 divided by 5. Okay, so this range comes to, or rather this class width comes to 22.2, and then we round this up to 23. Right, so our class width is going to be 23. Right, so first thing we do is we write the headings for our columns. So this is, this as number, right? So number of credits. What we are going to do is, to make things easy, we can just start at 9. So we'll start our frequency distribution at 9. So 9 is the lower limit of the first class, right? So 9, then we list the other lower limits for the other classes. So we get 9. The next one will be 9 plus 23, which is 32. 32 plus 23, 55. Then 78. And then 101. Okay, so these are our lower class limits. And then the upper class limits, we will have 31. We will have 54. 77, 100, and then 123. Okay, and then of course here is our total. So this is the total. Right, so let's look at the next question. Right, so we have answered the first question, which says we want to create a frequency distribution with 5 classes. What class width should we use? We found that class width to be 23. And then what are the class limits of the 5 classes in our frequency distribution? Right, so we have covered that. We have written our upper and lower class limits. Find the frequency corresponding to each class. You can use tally marks to make your counting accurate. Okay, so the next question then is to fill in our frequencies. Okay, so frequency. Right, I want to use tally marks because the numbers are already rank ordered, so it's easy to count. So the first, so from 9 to 31 there, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so the first frequency there for the first class is 12. Right, and then from 32 to 54, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right, so that's 14. And then from 55 to 77, from 55 to 77, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so 11. And then from 78 to 100, from 78 to 100, right? So we don't have 77, we don't have 78, we don't have 79. So we start at 80. So 1, 2, 3, 4, right? So 4 from 78 to 100. Then from 101 to 123, 1, 2, 3, 4, 5, 6. Right? So the rest of the numbers are 6. Right? So our total has to be 47. Right? So 47. You can just verify the total. Okay, so that's 47. So we are done with the second or the third part of this question. And then the next part says, find the midpoint for each class. Right, so we need midpoint. So the midpoint. So midpoint for each class. Okay, so the midpoint for each class, how do we calculate the midpoint? We add the lower limit of the class plus the upper limit and then divide that by 2. So 9 plus 31 divided by 2. 9 plus 31 is 40, divided by 2 is 20. Right, so for the next class, we do the same, but to make it easy, we just add, after we calculate the first class, we can just add the class width of 23. So if we add 23 to the midpoint of the first class, it will land us to the midpoint of the second class. So 20 plus 23 becomes 43. Right, so 43 is the mid-class of the midpoint of the second class. You can verify that by adding 32 to 54 and then dividing by 2. It will get you to 43. Right, and then from 43 we add our class width. We get 66. And then 66 plus 23 we get 89, and then 89 plus 23 we get 112. Okay, so these are the midpoints of our classes, right? So the next part of the question is asking us to come up with, to find the class boundaries, right? So class boundaries. Okay, so let's have a look. So class boundaries. Okay, so the class boundaries, remember, these are numbers that are midway between the classes, right? So numbers that are midway between our classes, right? So, and then the class boundaries have to have an upper boundary and a lower boundary as well. Okay, so the lower boundary of the first class will be 8.5. The upper boundary of the first class, which is a number midway between 31 and 32, right? So that number is 31 plus 32 divided by 2, which is 31.5. Okay, so 31.5. Okay, and then we have, for the second class, we have 31.5 all the way to a number that is midway between 54 and 55, right? So that is 54.5. 54.5. What then happens is you can add, to find the lower boundary of the next class, you just add the class width to 31.5. If you add 23 to 31.5, it will get us to 54.5, right? Then we add 23 again to 54.5, we get to 77.5, right? And then 77.5 plus 23, we get to 100.5. Okay, and then we find the upper limit, right? For the first one, we have 54.5 plus 23, we get 77.5, right? And then remember that the upper limit, right, of the previous class is actually the lower limit of the next class, right? So the upper limit of the previous class is the lower limit of the next class. So it's important to note that, because the the numbers of the classes the boundaries have to overlap. That's why they are called class boundaries. Okay, so and then for the next one, it's 100.5. Okay, 100.5 plus 23 gets us to 123.5. Okay, so these are our class boundaries for our 5 classes. Right, so the next question is construct a relative frequency for this data. So we need relative frequency. Okay, so relative frequency. So what I'm going to do is to express this relative frequency in percentage form. Okay, how do you calculate relative frequency? So relative frequency is the frequency of every class relative to the total frequency. In the first class, we have 12, right? So 12 relative to the total frequency is going to be 12 relative to 47, which in other words is 12 over 47, right? And then as a decimal, that number would come to 0.2553, but as a percentage, it will come to 25.53%. So that's our relative frequency. And then the relative frequency for the next class is 14 over 47 times 100. And as a percentage, so that becomes 29.79. For the next class, is 11 over 47 times 100. It comes to 23.40. And then the next one is 8.51%. And lastly, we have 12.77%. Okay, so the total there has to be 100. As we add the relative frequencies, we have to get to 100%. So next question is, right, so construct a cumulative frequency distribution for the data. So cumulative frequency. There are two ways to construct a cumulative frequency. You can use either a cumulative relative frequency or a cumulative frequency, right? So for instance, you can use cumulative frequency where you add successive frequencies, or you can use cumulative relative frequency where you add successive relative frequencies. But since the question is asking specifically for a cumulative frequency, then what we'll do is we will use the frequencies, right, so that we get a cumulative frequency, right? So how do we do it? So we add successive frequencies. The frequency for the first class is 12. The frequency for the next class, so for the first class is 12. We add that to the frequency of the second class, which is 14. So 14 plus 12 gives us 26. We add this 26 to the frequency of the next class. So 26 plus 11 gives us 37. Then 37 plus 4 gives us 41. And then 41 plus 6 gives us 47. Right? So that's our cumulative frequency. Okay? So if we wanted, though, we could use cumulative relative frequency. In that instance, we'll be adding successive relative frequencies. So the frequency for the first, if we are calculating it as a cumulative relative frequency, the frequency for the first class would be 25.53. And then 25.53 plus 29.79 would give us 55.32. And then this plus 23.4 gives us 78.72. And then this plus 8 gives us 87.23. Then 87.23 plus 12.77 gives us 100%. Okay, so that's cumulative relative frequency. Okay, so what is our next question? So our next question is to construct a histogram for this data. And then after we construct a histogram, we are asked to create a cumulative frequency curve for this data. Right, so let's go on to create those two charts. Okay, so now we are going to construct our histogram. So for our histogram, what we need to understand is so for a histogram, so let's do this histogram. So on the x-axis, we are going to have our class boundaries for the x-axis, right? And then on our y-axis, we can have our frequencies or relative frequency, right? So that means on the y-axis, we'll have some form of frequency. Okay, so on the y-axis, what we are going to have in this instance, we'll use our frequency. We'll start at 0. We'll have 2, 4, 6, 8, 10, 12, 14, 16. Right, and then on the x-axis, right, on the x-axis, we'll use our class boundaries. So we'll have 8.5. 8.5, okay, and then we will have 31.5, 31.5, okay, and the next one is 54.5, 54.5, and then 77.5, and then 100.5. Lastly, 123.5. Okay, so the first bar of our histogram should be at 12, right? So from 8.5 to 31.5, we have 12, a frequency of 12, right? So 12. Okay, so that is our first bar, right? And then the second bar is 14, right? So 31.5 to 54.5, we have 13, rather 14, right? So 14, right? So the bars may not be as accurate as we want them to be, just because I'm using freehand here. But remember that the rule is that for a histogram, the bars have to have the same width, right? So just keep that in mind. So the next one is 54.5 to 77.5. So we have 11 for that. So 11 is somewhere here between 10 and 12. So it will be somewhere there. And then the next one is 4, right? So 77.5 to 105 to 100.5. So that's 4, right? 4 is here. We have 4. Okay, and then lastly we have 6, 100.5 to 123.5. We have 6. Right? So 6 is somewhere there. So that's 6, like that, right? So this is our histogram. And then again, remember with a histogram, you have to label it. So you will have a title there, right? You give your histogram a title, right? And then you label the axes. So this is frequency. Okay. And here we have number of credits. That's that. So that's our histogram. So lastly, we are asked to create a cumulative frequency curve for this data. So let's create a cumulative frequency curve. So for a cumulative frequency curve, we need, what do we need? So on the x-axis, we need the upper class limits. So upper class limits or boundaries. In this case, we'll use boundaries, upper class boundaries, right? And then on the y-axis, since it's a cumulative frequency curve, we need the cumulative frequency. First, we'll draw our axis. So here is our y-axis, right? And then our x-axis. Okay, so on the x-axis will start, rather on the y-axis will start at 0. And then remember that our frequency is cumulative, so it goes all the way to a total of 47. Right, so let's see how we can break this up. Right, so we can start at, let's say, 5, 10, 15, 20, 25, right, 30, 35, 40, 45. Okay, so we'll need to extend our axis here. Right, so remember with the x-axis, we need the class boundaries, right, or the upper class boundaries or upper class limits. So we will use the upper class boundaries here. So we have 31, 54, 77, 100, and 123. Okay, so we have 31.5, we have 54.5, we have 77.5, we have 100.5, and 123.5. So let's do our best now to plot this cumulative frequency curve, right? So the first point that we need, remember that we are, for a cumulative frequency distribution of cumulative frequency curve, we are just plotting the points and then using a line to join them, right? So the first point is going to be, right, on the x-axis we have 31.5, and then on the y-axis we have 12, right? 31.5, 12. So 31.5 and 12, so 12 would be somewhere here, right? So 12, that's our point. And then the next one is 54.5, 26, right? So 54.5, 26. So 26 would be way up here, 26, right? And then we have 77.5. So this is 77.5 here, 77.5, and the frequency there is 37. So 37, 30, so if 35 is here, 40 is here, so 37 would be somewhere here, right? And then we have 105, so 105, and 41, so this is 40, so 41 would be here. Okay, and then 123, right? So 123 corresponds with a frequency of 47. So this is 45, so 47 would be somewhere there, right? 40. Okay, and then you can do your best to draw a line, right, to join our dots, right? And then you get something like that. Okay, so this is what we call a cumulative frequency curve.